Welcome to AI Podcast. I'm Ethan, and today we're unpacking a recent ACL industry track paper about building more reliable AI agents. Here's the quick TLDR so you can decide if you want to keep listening. The authors propose a two-part recipe called Leap and Lean. Leap is a small dose of look-ahead planning that explores likely next actions before committing. Lean is a way to keep the prompt minimal and focused so the model doesn't get distracted. Together, they deliver more consistent results than familiar agent templates like React, and they do it without any fine-tuning.
Nice, clear starting point. So the core idea is plan a little smarter, then keep the model's attention tight. I'm with you.
Exactly. And to give proper credit, the paper is by Nikhil Verma and Manasa Bharadwaj from LG Electronics Toronto AI Lab, published in the ACL 2025 industry track. I like that the emphasis is on practical gains and deployable design choices, not just benchmark heroics.
Good to know who's behind it. Before we get into the mechanics, can we set the stage? What's the problem space they're tackling?
The backdrop is the current wave of large language model-based agents, the kind that browse, plan, and call tools. They can do a lot, but they still stumble in day-to-day use. Typical failure modes include suggesting actions that don't exist, looping because the prompt keeps accreting irrelevant context, or taking steps based on general knowledge rather than the actual state. Those issues get worse when you try to keep costs down with smaller models, or when you limit the number of steps the agent can take.
So the friction is very practical. Agents hallucinate actions, waste steps, and sometimes chase their own tails because the prompt keeps getting longer and noisier. That sounds familiar.
It is. Prior research has attacked this in two main ways. One thread uses learning-heavy approaches like imitation learning or reinforcement learning, which can work but need curated data, fine-tuning, and real engineering lift. Another thread leans on prompting tactics like chain of thought or React. Those help, but they can become brittle in large action spaces and often assume you're using a very capable and therefore expensive model. In short, teams have had to choose between heavyweight training pipelines and prompt tricks that don't always scale.
Right. Either you spend a lot to train and maintain, or you try to coax the model with prompts and hope it generalizes. So where do Leap and Lean fit?
The authors split the agent's decision-making into two clean loops. Leap is the look ahead. At each step, instead of jumping straight to one action, the system briefly explores several plausible next moves and what they would likely yield. The goal isn't exhaustive tree search. It's a lightweight preview that surfaces a short list of promising candidates.
So it's like peeking a few squares ahead in a board game, not playing out the entire match. That keeps the agent from missing an obviously better move.
Exactly. Then Lean kicks in. If Leap is about breadth, Lean is about focus. The agent composes a trimmed, highly relevant prompt for the language model. It includes just the right slices of context and the shortlisted options. The model then reasons briefly and picks the best next action. The claim is that this two-step handoff reduces action hallucinations, avoids analysis paralysis from bloated prompts, and keeps the agent grounded in the current state.
That sounds reasonable. A little exploration, then a clean decision. How did they test it?
They covered three quite different settings to show the method isn't tied to one niche. First, a web shopping environment called Web Shop, where the agent has to find and buy items that match a user's description. Second, ALF World, a text-based embodied environment where the agent navigates rooms and interacts with objects to complete everyday tasks. Third, a travel planning scenario that is more like pure constraint-based planning rather than step-by-step navigation.
So shopping on the web, moving around in a simulated home, and building itineraries with constraints. Good spread. What did they compare against?
They used common prompting baselines, especially React, and they tried both mid-sized open-source models and an API model. They also tested a small variation where a reward model helps pre-rank options in the shopping task, which is a practical way to cut search overhead.
Got it. And how did it turn out?
The headline is Consistent Improvement. In the web shopping task, the leap and lean combination delivered higher success rates than React across both kinds of models. In Aleph World, the gains were especially pronounced, and the agent finished tasks in fewer turns because it wasn't meandering. In the travel planning setting, the improvements were more modest, but the method still matched or beat simple, direct prompting and standard chain of thought.
So the biggest jump shows up in the embodied navigation, where low-level choices matter and getting stuck is costly. That makes sense. If you look ahead a little, you're less likely to open the wrong drawer 3 times in a row.
Exactly. One detail I appreciated is that the method is practical. They don't assume unlimited compute. For example, in the embodied setting, they throttle the look ahead so it runs periodically rather than at every single step. And because lean narrows the prompt, you often don't need extra model calls to decide among the shortlisted options.
That matters if you're thinking about deploying an agent in production. Latency, token cost, and predictability all count. Were there any caveats?
A few, and they're worth noting. Even small doses of look-ahead add overhead, and in very open-ended environments, naive previews could become expensive. The comparisons lean on familiar templates like React, so stronger agents with richer memory or tooling could change the picture. And in the shopping benchmark, there's a trade-off to watch. Success rate improves reliably, but a secondary match quality score can sometimes dip when you combine leap with lean, which suggests the system prefers safer choices from the shortlist.
I like that they acknowledge those trade-offs. I'm also wondering about reproducibility. Any signals there?
They use public benchmarks and common models with deterministic decoding and fixed step limits, which helps. But with agents, details like prompts and environment dynamics matter. A thorough open-source release of code and prompts would make replication even easier.
That's fair. From a practitioner's standpoint, what are the most actionable takeaways?
3 things. First, separate planning from prompting. Even a small amount of look ahead pays off when the action space is large or your model is modest. Second, be ruthless about prompt content. A lean prompt that spotlights the immediate choice can beat a long history that dilutes attention. Third, where the domain allows it, add a lightweight pre-ranker to shrink the choice set before the model thinks, especially in search-heavy tasks.
That's a useful checklist. If I were building a support automation agent, I'd have the system preview a few next steps, shortlist them, and then ask the model to decide using only the critical context. No need to paste the entire ticket history every time.
Exactly. And if you're tracking costs, you can adapt the look-ahead frequency based on budget or uncertainty. Run leap less often when the situation is clear, and more often when the agent seems unsure or the action space suddenly widens.
Makes sense. Before we wrap, what future directions would you suggest?
Smarter planning under a fixed budget, like bounded tree search or adaptive depth, so you keep the benefits of foresight without surprises in latency. Less heuristic prompt selection, ideally learned retrieval of the pieces of context that actually change outcomes. Broader benchmarking against newer agent stacks in noisier or partially observable settings, and clearer reporting on wall clock time and token costs to help teams choose the right quality-cost trade-off.
That's a solid roadmap. I like that this paper sits between simple prompting tricks and heavy training. It gives teams a way to make agents sturdier with tools they already have.
To close the loop, the contribution is a practical blueprint. Use a brief look ahead to avoid blind spots, then keep the decision prompt crisp and targeted. Across shopping, embodied tasks, and planning, that combination consistently improves reliability without fine-tuning. It isn't the final word on agents, but it's a meaningful step forward.
Thanks. This has been calm, clear, and actionable. If you want us to cover another paper or a hands-on implementation, let us know.
This has been AI Podcast. I'm Ethan.
And I'm Maya. Thanks for listening.